we are group 10. Today we will be demonstrating our assignment for implementing Quickhull algorithm for convex hull construction. We have extended our basic 2D Quickhull method for 3-dimensional as well as included dynamic hull updates, that is we can add or delete a point and the hull will get updated accordingly. This is very useful in autonomous vehicles, drones and AR/VR systems where the system continuously captures 3D points from the environment. Into the demo. So currently we are in the 2D mode. We can select the number of points and then click on generate. First, it identifies 2 points with minimum and maximum coordinate. The line segment joining these points divides the canvas in two parts, that is the upper part and the lower part. For each subset, it finds the farthest point from the current line and eliminates all the points inside the triangle. Then recursively applies this process to two new line segments found until no more point remains in the subset. Now we can also add a new point and delete a point. For example, I want to add a point with the coordinate, say 600x coordinate and 540 y coordinate. So the addition uses incremental algorithm. It first determines the portion of current convex hull visible from the new point. This involves finding two tangent points on existing hull from the new point. The visible edges are then replaced by two edges connecting the new point to the two tangent points on the hull. We can also delete a point here. To delete a point, we'll enter the coordinate. I want to delete this point, so 132 and 466. 132 and 466. So to delete the point, the hull will first connect the two neighbors, say X and Y, to form a temporary hull. Then identified points lying outside the hull. Of these points, we find the farthest point from the line segment XY, say Z, and then recursively continue till similar to the Quickhull algorithm, as you can see here. Example. Now, let's take number of point as 30 and then click generate. Again, two farthest points where the X coordinates are selected, then a point farthest to this line segment in upper half, then the lower half, and the algorithm is repeated recursively till the hull is formed, as you can see. Let's see the demo for the 3D mode. Say the number of points are 19 and then generate. So it first identifies four non-coplanar points to form initial tetrahedron. Then it divides the remaining points according to faces of tetrahedron, similar to the above and below approach in 2-dimensional. We can also add a new point. Say we are 0, 0, 0. So for adding, it removes the visible faces and create new triangular faces connecting farthest point to horizontal edges, and then repeats until no points are left outside, as you can see. You can also rotate it to see it in a different dimension along each axis and so on. Let's see one more example for our 3D implementation. Say the number of points are 25 and now generate, and the similar approach is repeated, that is an initial tetrahedron and then the farthest point from each face. That was it's created. That was all for our demo. Thank you so much.